Alright, we're going to talk about generating numerical patterns from rules, input-output table rules. So let's say, what I mean is, if I were to give you a rule, let's say, a rule is just an instructions you follow on an input. Okay? Meaning, if I were to say y equals x plus a, or let's say y equals x plus 7. This rule, x, in this rule, x is the input. We were to write an input-output table. X would be the input, and y is the output. And the way we get numerical patterns out of this is that we have x, the input, and we follow these instructions with each input. If I were to input 1 into this, well, I just replace this equation would now be, this rule would now be 1 plus 7. 1 plus 7 is 8, and then I use, so y would be equal to 8, which means the output for 1 would be equal to 8. And then we keep going. And we do, let's say the input, instead of 1, it's 2. Then x would be equal to 2, and it would be y equals 2 plus 7. And this is how rules work. So 2 plus 7 is 9. And then we just keep generating a numerical pattern from this. Let's do it with 3. 3 plus 7 is 10. So, and 4 would be 11. So the pattern for 1, 2, 3, and 4 is 8, 9, 10, 11. And the pattern is that we add 8. But what about the rule of 11, 3 times x? 3 times x. This x is the input, and this y is going to be the output. Let's write an input-output table. Let's write a numerical pattern. Let's say for the numbers 7, 10, 12, and 15. Okay? Well, let's start with 7. 7's, if x is the input, then let's start with 7. 7's the input. 3 times 7 is 21. If 10's the input, that means 10 is x. 3 times x, or 3 times 10, is 30. If 12's x, which is the input, 12's input, 3 times 12 is 36. If 15's the input, that means 15 would be x in this situation. Then 3 times 15 is, give me 1 second, 45. 45. And this would be our numerical pattern given these inputs and given this rule. So y is the output, x would be the input. You just follow the rules to get the output. 3 times the input, and then we get the output. That's how rules work. All right. One more. Let's say we have the input y, the rule y is equal to 2 times x plus 5. This one is a bit more tricky. So what if let's write down this input-output table. This is input, this is the output. Let's do it just for 1, 2, 3, and 4. With 1 as input, 1 as x, 2 times 1 is equal to 2, and then 2 plus 5 is be equal to 7. So y would be equal to 7 in that case. What about with 2 as the input? 2 as x. And this would be 2 times 2, which is 4, plus 5, which is 9. So then y would be equal to 9. The output would be equal to 9. What about 3 as the input? 3 is x. Well, 3 times 2 times 3 is 6. And then 6 plus 5 is 11. So then the output would be 11. Y would be 11. What about 4 as an input? 4 is x. 2 times 4 would be 8. 8 plus 5 would be, ow, my eyes. 8 plus 5 would be 13. So y would be 13, or the output would be 13. And this would be the numerical pattern. And you can kind of see it goes up by 2 each time. 7 plus 2 is 9. 9 plus 2 is 11. And 11 plus 2 is 3. So you could also have written this as, I guess, 2x. Well, no, you couldn't have, but whatever. You know what I'm saying. Okay, well, bye, c'est trop.